Now then, looking at this other sheet, the formats, I've kind of listed these underneath for you because you're not totally familiar with them. The text record you should know. Those are fairly straightforward. Notice the first text record, you have 0 as the address. That's the starting address of this record. And then the 1B. What's the 1B? The length of the record. It's in hex, right? So how many bytes is that? How many bytes is that? In decimals.
27.
27, yes. And then the 6923D8. Does everybody see the 6923D8? That's your first executable instruction. So we go along here then, and you fill up each text record as much as you can, and start a new one when you must. And when must you is one, you run to the end, or you have a change of address. I.e., the next thing is not sequential for its address. What would be a situation like that? Can you give me an example of a time when you would need to finish a text record and start a new one before you got to the end of the column, end of the line? Like maybe the fourth one. You see the fourth line there, the fourth text record? Address is 5.1. Why doesn't that keep going? Why is there a new one started? Wouldn't it fit? What's that? It's a jump. That is, alpha reserves 300 bytes of memory. Therefore, the next address or the next piece of object code is not sequential. Right, so that's why some of the lines are short, when in fact, if you were to stack them all up, they would actually fit, but you can't fit because there's a change in address. Is this clear to everybody? So when you hit this instruction, reserve word 100, what goes in memory? Nothing. What's the effect of that instruction? Reserve word 100. The effect of this is you have to start a new text record with an address moved down by 300 bytes. That's what the effect of it is. Okay. So I want particularly to focus on the modification records here. The modification record. So the format of this is column 1 is an M, and then 2 through 7 is the address of the field to be modified. The address of the field to be modified. So what is the address of the first instruction that needs changing? Which one did we decide needs changing, the first one? At what address? 6. The first one we identified a format for that needs modification is an address 6. So why do we have M00000705? Is 7 the address? Yes, it is. All right, so let's look at this piece. What do we have here? We have 0, 6, 1, 0, 0. Okay, what are the pieces of this? You have how many digits for the opcode and the flags NIX, How many hex digits is that? What part of this instruction is the opcode and the flags? And what part of it is the address? No? It's not. So my question is, where does the address start? What is the address here? 6. So we have at food. What's the address of food? 00F9F. So where does it start? Oh dear. Now, what's the first part here? Well, this is the opcode and the NIX BPE flags. That's what that is. And this is the address. So this is 6, 7, 8, 9, and so on. So, go to address 7. So that is the address of the address that needs modification. It's an address of the address. Okay, so address 7 is where we need to go. We need to go right here. Now, the next thing we need is the size. And the size is 5 half bytes. Okay, what's a half byte? What's a half byte? What does that mean? Yeah. There's another term for it. Do you know what it is for a half a byte? A nibble. A nibble. Yes, there's nibbles and bytes. Somebody was fun. Right? So this is confusing, and I hope you all can get this and understand. It's 5 half bytes. 1, 2, 3, 4, 5. 5 half bytes. So it splits this byte in half, and these 5 digits have to be transformed, have to be modified. What we have here is a listing of all the things that have to be modified when the program is actually loaded and run. So let's make an assumption here. Let's assume that our program is going to load at address 0, 1, 0, 4, 3. Just made it up. So what now has to happen? How do we modify this thing? Add it. So we have 0, 0, F, 9, F, plus 0, 1, 0, 4, 3. Okay. After 3 is 18. A, 4, E, F, 1, C. So we go to, as we're loading this thing, this piece of memory, we change this. 0, 1, F, E, 2. That's what's actually loaded into memory as modified by below the. So is 01 FE2 exactly where food will be in this instance of the running program? The answer is yes, it is. Yes, it is. All right, let's do the next one. We'll keep that loaded address. The next address plus LDA beta comma X. All right, let's look at the code. We have 0, 3, 9. And then we have 0, 0, 1, 8, 3. And 183, of course, is beta. Okay, so we look at the modification record and we can see we need to go to B and take 5 half bytes. All right, well, this starts at A. Those are the addresses. We take the last 5 digits, the 20-bit address, and add it. 011C6. And that transforms it to the actual address of where it would be. Questions? Okay. Now suppose that the size isn't 5 half bytes. Oh, is that possible? Can you give me, okay, let me say this, it is possible. Give me an example of something. Something. It would not be 5 half bytes. But it needs modifier. I mean, what's the point of giving the length in half bytes if it could only be one size? The answer is it can't. It isn't only one size. What else could it be? Suppose we have a new entry at address 00FA2. That's your last address in this. That's your last address. And suppose I say bar word. Is that a legal instruction? Is that a legal declaration? Okay, well, it's a word. How many bytes is a word? 3, and what does it have in it? The address of alpha. So what is it going to look like? Well, looking here at the address of alpha, we have right? So tell me what the modification record is going to look like. What is the modification record? And now we need the address, which is 2 through 7. then what is the address of the instruction that's going to need modification? Right? Is that the address that's going to need modifying? Or is it FA3? And the other, for one more, what's this? What does it need to be? Is it this? No. What is it? So the address is 2 through 7. So that needs an extra 0. Is the address right? Yes, no, maybe. All of the other ones, notice we did 6, but in the modification record it's 7. A, in the modification record it's B, the address. Is this the address? Sure, it's the address of what we need to modify. Well, how's that going to change? Well, this isn't going to be 5.7. Not if we load this in a different place. So we're going to have to change this. So the address here, FA2, is right. And how many half bytes is it? 6. Yep. 6 half bytes. Good. Okay. So that would make the modification record for this. It's not always 5 half bytes. It can be 6. Okay. Questions? Anyone? No questions. You guys are easy. So, okay, I'm going to stop there today. We'll let you go a little bit early. Next time I want to do a worksheet